Okay, here is Unit 7, FRQA number 2. Now, this one is pretty cool. This one's got some slope fields going on. This one shouldn't take us but too long. All right. Now, what we're going to do here is whenever they ask you to do a slope field, you want to make sure that you make your answer look obvious enough. I'm going to try a black pen, see if it shows up really well. Consider the differential equation that, on the axes provided, sketch a slope field for the given at the 9 points indicated. All right, well, what's cool about this is whenever x is equal to 0, the slope is going to equal 0. Whenever y is equal to 0, the slope is going to equal 0. So we're going to have 0 slopes and here, and here, and here, and here, and here. 6, 5, 1, 4. The 5 of those are going to be 0 slopes. But then at the point 1, 1, 1 times 1 is 1. Here, 1 times 1, 1 times 1 is 1. Interesting. Here, negative 1 times 1 is negative 1. And here, negative 1 times negative 1 to the 4th, which is positive 1, negative 1 times 1 is negative 1. And there we go. Okay, there's a complete slope field right there for the 9 points indicated. No need for them drawing. If they ever ask you to draw something, you could like sketch it through, whatever it is. A little bit of an interesting slope field. Okay, so now part B, this is kind of cool. Part B says, let's find our second derivative, which is cool, and then determine the concavity. And remember, if our concavity is positive, if our second derivative is positive, it's concave up. If our second derivative is negative, it's concave down. So here we go. Second derivative of the original y is the first derivative of the first derivative. Looks like we're going to need to do a little product rule. All right, so my second derivative, I like the purple one better, is, I'm going to go first times the derivative of the second. Here's a little chain rule built in here too, because the derivative of something to the 4th is 4y cubed times the derivative of something, y prime. Every time you're doing implicit differentiation, 4y cubed y prime, tack on that y prime, plus second times the derivative of the first, which is 1. So this is just 4x, excuse me, 4x y cubed y prime plus y to the 4th. But we know what y prime is. We know what y prime is. It's that. And if we're in the second quadrant, well, we should clean this up a little bit, eh? Okay, so that's going to be 4xy cubed y prime, which is xy to the 4th, plus y to the 4th. So in total, we've got 4, we got 2 x's, so x squared. We got y to the 7th plus y to the 4th. So now they want us to determine whether all the solutions in quadrant 2, which is negative positive, all my y values are positive, all my x values are negative, what type of concavity. But if you'll notice, my x value here is squared, so that's always positive. My y values in quadrant 2, my y values, since I'm in quadrant 2, are also positive, so that's a positive, that's a positive. So I'm going to have all positive values. So I'm going to have a positive. That's going to be greater than, I'm a little nervous about that notation, so maybe just saying greater than 0. But what is my concavity? So concave up, because second derivative in quadrant 2 is positive. Okay, part C. Now part C, so fun. Part C, all we got to do is do a good old differential equation, find the particular solution, which immediately should tell you separate and integrate. So I'm going to bring up here, I'm going to bring the y to the 4th over, 1 over y to the 4th. And then I'm going to bring leave my x up there, and here I go, typically guaranteed 5 points. So now I'm going to integrate both sides. I love these, except I'm not really sure how to integrate 1 over y to the 4th. So I'm going to call it y to the negative 4th instead. So now I can do my unpower rule. Negative 1/3 y to the negative 3, because I'm bringing my power up by 1, equals 1/2 x squared plus my constant, of course. So I've got, what is this? Negative 1 over y cubed equals half of x squared plus c. Let's shove in this initial condition. For negative 1, I'm going to travel up here. So negative 1 over negative 1 cubed equals 1/2 of 4 squared plus c. So negative 1 over negative 1 is positive 1 equals half of 16. So it looks to me, oh, I forgot the 3. I forgot the 3. Whoopsie. Let's go back here. 3. Negative 1 over 3. So this is negative 1. This is negative 1 over negative 1. Negative 1 cubed is negative 1. So I've got a negative 1 over negative 3. Negative 1 over negative 3. So 1/3 equals half of 16, 8 plus c. So c is 1/3 minus 24 thirds, 24 thirds, 24 thirds, negative 23 thirds. Ew, that wasn't as pretty as what it would have been up there, but this is definitely correct. So now I'm going to stick that into here or here and bring it all the way up here. Bring it around town. Negative 1 over 3y cubed equals 1/2 x squared minus 23 thirds. Ugh. Okay, so now somehow carefully I got to get y all by itself. So I think if we do the old flippy flip, I'm going to make this a common denominator. I'm just going to work on this right hand side for a minute. I'm going to make this 6. So multiply this by 3 over 3. So I've got 3x squared minus, multiply this one by 2 over 2, 46 all over 6. So this is nice because now negative 1 over 3y cubed is 3x squared minus 46 all over 6. Now I'm going to flip both sides, or I'm going to bring, you can do algebraically whatever you want here, but my y cubed is going to come up here as this entire thing comes down here. Okay. Maybe what I'll do is algebraically just pretend to cross multiply here. I'm not pretending, I'm actually going to. But like if I cross multiply here, 3y cubed times 3x squared minus 46 should equal negative 6. So far so good. So now I can get rid of that. That's a 2. So now y cubed is going to equal 2 over, I think it's a negative. Negative 2 over 33x squared minus 46. Okay. So it looks to me like y is the cube root of negative 2 over 3x squared minus 46. Okay, there's a good final answer. You could also write it in their form, which is positive 2 over 46 minus 3x squared. They just brought the negative down to here and flipped those two, which is completely fine, of course. But, of course, either one of your answer forms would be fine. So it's kind of a fun little problem. Little slope field, little second derivative, concavity, and our good old friend particular solution. Solve for y, and make sure I didn't miss anything they asked me to do. And there it is. All right, thank you.